Hello, in this video we'll be talking about standard forms, also called scientific notations. Standard form is an easy way of expressing relatively large numbers. As an example, the mass of the Earth. The mass of the Earth is a very large number. To write out the mass of the Earth explicitly, we need at least 25 distinct whole numbers. But we can write the mass of the Earth simply by using the standard form. And the mass of the Earth is equal to 5.98 times 10 raised to power 24 kilograms. Now imagine that we had to write this number out. This would be such a long number. And this form, writing numbers in this form, is exactly what is called the standard form. Before we start to write numbers in the standard form, I would like us to revise two things. The first is, what happens when we multiply or divide numbers by 10 and multiples of 10? And the second is, we need to revise a law of indices that deals with negative powers. So the first one, imagine that we have a number 3.421 and we are asked to multiply this number by 10 and also asked to multiply the number by 1000. So if we compute this using our calculator, we would find that the result we will get is 34.21. And the result for this is going to be equal to 3,421. Now in these cases, you will notice that the decimal points have moved to the right. The number remains unchanged. But by how much did they move? Here, where we have 10 and 10, which is a quick way of remembering this. We have 10. The decimal place moved one place to the right. So it was 3.421 and now we have 34.21. And for here, which is 1000, which we have 3 zeros, the decimal place moves 3 places to the right. So from 3.421, we have 3,421. And I should also note that this is the same as multiplying by 10 raised to power 1, which is needless to write. And this is multiplying by 10 raised to power 3. Because 10 times 10 times 10 is 1000. 100 is 10 squared. I'm sure you're conversant with that by now. I just needed to mention it. Now, if we summarize that, what we're saying is that if we multiply by 10 raised to power n, then we move the decimal point n places to the right. Now what happens when we divide by 10? So if we're given a number 4526.8 and asked to divide this number by 10 and the same number 526.8 and we're dividing by 1000. Now this is the same as saying this is the same as saying 4526.8 multiplied by 1 over 10, and this is equal to 4526.8 multiplied by 1 over 1000. Now if we do this, what we would have is 452.68, and this is going to be equal to 4.5268. Now just like when we multiplied by 10, we moved the decimal point one place to the right. When we divide by 10, you would notice here that we moved the decimal point one place to the left. And in this case, we moved the decimal point 3 places to the left when we divide by 1000. And this is also the same as saying 1 over 10 raised to power 1, and this is the same as saying 1 over 10 raised to power 3. I hope this is not too messy. So to summarize this, if we divide by 10 raised to the power n, then we move decimal point n places to the left. So if we divide by 10 raised to the power n, then we move decimal points n places to the left, as we've seen here. Now the next thing I want us to look at before we start writing in standard forms is the law of indices that deals with negative power. If you've not seen my last video on laws of indices, please look at it. It proves the laws of indices and then applies it in solving real problems. And so the law that we're looking at that is of particular concern to us is the one that says that a raised to the power minus n is equal to 1 over a raised to the power n. So in this case, where we have 1 over 10 raised to the power 1, it means that with this law, we can be able to say that 1 raised to the power 10 raised to the power 1 is equal to 10 raised to the power minus 1, and 1 over 10 raised to the power 3 is equal to 10 raised to the power minus 3. The difference is that we're going from here to here. So 1 over 10 raised to the power 1 is equal to 10 raised to the power minus 1, as in this case. And in this case, a is 10 and 3 is n. So 1 over 10 raised to the power 3 is equal to 10 raised to the power minus 3. I hope that's clear. Now, let's start writing in standard forms. Numbers written in standard form takes this format, which is a multiplied by 10 raised to the power n. N can be any positive or negative whole number. One of the laws that we must respect before we write standard forms is that a has to be between 1 and 10. So we express a as a number between 1 and 10 inclusive, and then multiply by the needed power of 10 to bring the number to what we want. So first example, if we're asked to express 5720 in standard form, so I would advise that you write 5720 to the right of your equation to make it easier. And what you're thinking about is, first we have to write a as a number between 1 and 7, and then multiply it by a multiple of 10 to give us 5720. Now, the first number here is 5, so I would advise we write 5.720. 5.720 is definitely between 1 and 10. And that's the only way we can get any number between 1 and 10. We can't write 0.572 because that will be less than 1. And we can't write 57.2 because that will be more than 10. So the number we can express from here that is between 1 and 10 is 5.720. But then what do we need to multiply by 5.720 to give us 5,721? And that is, we have to multiply this by 1,000. If you multiply 5.720 by 1,000, you will get 5,720. And so, if we're going to write this out in standard form, this will be 5.720 times 10 raised to the power 3. And that's how you get that. If we do another example, which is write 474,000 in standard form. So we'll do the same thing, 474,000. Now, like we did for the first one, the number between 1 and 10 that can be obtained from this number is 4.74. And what do we need to multiply 4 by 4.74 to give us what we have here. And you notice that for that we had moved the decimal point 1, 2, 3, 4, 5 places. So we can multiply this by 1, 2, 3, 4, 5. We can multiply this by 100,000 to get 474,000. And that's going to result in the standard form as 4.74 times 10 raised to the power 5. And it's as simple as that. That's how we write numbers in standard form. We'll do more examples just so that we're conversant with it. If we were to express 82,647 in standard form, so that will be 82,647, 8.2647. I'm sure we're familiar with how we do this now. And we need to multiply that by 1, 2, 3, 4. 1, 2, 3, 4 to get 82,647. And so that's 8.2647 times 10 raised to the power 4. And that's that. The next example is 61,800,000,000 in standard form. So we do the same thing, 61,800. And the number between 1 and 10 that we can derive from here would be 6.18. Now we need to multiply this by, if we have our decimal point here like we have here, we need to multiply this by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's going to be equal to 6.18 times 10 raised to the power 10. And that's the answer in standard form. But what if we have a number less than 1? For example, if we're required to write 0.09 in standard form, we do the same thing, and in this case we also look for a number that we have to write between 1 and 10 from 0.09. And I would argue that 9 is a number we can get from here. But then what do we need to multiply or divide 9 by to get 0.09? And if we assume that there is a decimal point here like we normally would, we need to move the decimal place 2 points. We need to move the decimal point 2 places to the left to be able to get 0.09. And by so doing, we'll need to divide this by 100. Now, if we divide this by 100, that's the same as saying multiplied by 1 over 100, which is the same as saying 9 times 1 over 10 raised to the power 2. And this is the same as saying 9 times 10 raised to the power minus 2. And that is writing that in standard form. So the next example is 0.0032, which is another number less than 1. So we do the same thing, 0.0032. We can get the number 3.2 here. Now, what do we need to divide this by to result in 0.0032? And we would need to move the decimal point 3 places to the left. That means we need to divide this by 1000, which is equal to 3.2 multiplied by 1 over 1000, which is equal to 3.2 multiplied by 1 over 10 raised to the power 3, which is equal to 3.2 multiplied by 10 raised to the power minus 3, I'm hoping that when you get used to this, you don't have to do all these steps. But the only reason I do all this is so that it's clear as to how we arrive at this number. I'm sure that when you're conversant with this, you don't need to do all these long processes anymore. Now the next one is 0.000097, and we want to write this in standard form as well. So the number between 1 and 10 that we can write is 9.75. And from here, we can see that we need to move the decimal point 1, 2, 3, 4, 5, 6. 6 places, which is 1, 2, 3, 4, 5, 6. And so, oh, no, that was divided by, not multiplied by. So that will be 9.7 multiplied by 1 over 1 million, which is the same as 9.7 multiplied by 1 over 10 raised to the power 6, which is the same as 9.7 multiplied by 10 raised to the power minus 6. And that's the standard form for that. Now, that's all about writing numbers in standard form, actually. But standard forms can help us solve problems easier. So imagine you have a question that says 40,000 multiplied by 2 million. Now to get this, you would probably need a calculator or start counting the zeros and all that. But we could express this in standard form, and that will be 4 times 10 raised to the power 4. And this is 2 times 10 raised to the power 6. Now we have to multiply this 2. Now we can do that by saying 4 multiplied by 2, which is this multiplied by this, and then 10 raised to the power 4 multiplied by 10 raised to the power 6. Now if we do this, this will be equal to 4 times 2 is 8, and 10 raised to the power 4 multiplied by 10 raised to the power 6. Now to evaluate that, we would use the law of indices that says that a raised to the power m multiplied by a raised to the power n is equal to a raised to the power m plus n. And so this is going to result in a, which is 10, raised to the power 4 plus 6. And the answer to this is going to be 8 raised to the power 10. A multiplied by 10 raised to the power 10. And that's how standard form also helps us to solve problems easier. So if we'll take more examples, if we're asked to evaluate 8 times 10 raised to the power 6 multiplied by 3 times 10 raised to the power 5. So we do the same thing. This is going to be 8 multiplied by 3 multiplied by 10 raised to the power 6 multiplied by 10 raised to the power 5. So 8 times 3 is 24 multiplied by 10 raised to the power 6 plus 5. And that's going to be 24 multiplied by 10 raised to the power 11. But there's a problem here. The problem is that we know that when we express numbers in standard form, the a part of the number should be between 1 and 10, but 24 is not. So we have to reduce this to something between 1 and 10, and what we can derive from here is 2.4. Now, in order to do that, we have to divide this by 10, but the 10 is not going to be lost, so we have to increase the power here by 10, because we're taking away one value of 10 from here. We have to increase the other side by a value of 10, and so this is going to be equal to 2.4 multiplied by 10 raised to the power 12, and this is the final answer. So the next question is 2 times 10 raised to the power 6 multiplied by 3 times 10 raised to the power minus 3. Now, this is going to result in 2 times 3 times 10 raised to the power 6 plus minus 3. That's plus this plus this. And this is going to be equal to 6 multiplied by 10 raised to power 6. Plus times minus is minus, so 6 minus 3. And the final answer for that is 6 times 10 raised to power 3. We can also solve division using this standard form way out. So if we have a problem such as 4.8 times 10 raised to power 12 divided by 1.2 times 10 raised to power 2. So in this case, what we have is 4.8 divided by 1.2 times 10 raised to power 12 divided by 10 raised to power 2. Now, just for clarification, how did we get here? Imagine that we have 4.8 times 10 raised to power 12 divided by 1.2 times 10 raised to power 2. This is the same as saying 4.8 over 1.2 multiplied by 10 raised to power 12 over 10 raised to power 2. So 4.8 divided by 1.2 is what we have here, multiplied by 10 raised to power 12 over 10 squared is what we have here. I hope that's clear. So I don't have to explain that in subsequent solutions. Now here we'll be using a law that says that a raised to power m divided by a raised to power n is equal to a raised to power m minus n. So 4.8 divided by 1.2 is equal to 4. And 10 raised to power 12 divided by 10 squared is equal to 10. 12 minus 2. So the final answer for this is going to be 4 times 10 raised to power 10. The next question says 3.6 times 10 raised to power 8 divided by 9 times 10 raised to power 3. So we solve like we solved the last time, which is 3.6 divided by 9 multiplied by 10 raised to power 8 divided by 10 raised to power 3. Now 3.6 divided by 9 is equal to 0.4, and 10 raised to power 8 divided by 10 raised to power 3 is 10 raised to power 8 minus 3, which is equal to 0.4 times 10 raised to power 5. Now there's also a problem here because 0.4 is not between 1 and 10. This is less than 1. Now we need to make this more than 1 but less than 10. And we can move the decimal point one place to the right, which will be equal to 4. But we've increased this side by a value of 10. And so to still keep this expression, we need to reduce the 10 from here. So this is going to be 4 times 10 raised to power 4. And that's the answer. We can also solve addition problems. And the first example we'll be looking at is 6 times 10 raised to power 5 plus 3 times 10 raised to power 6. But addition is different because we can't solve like we solved for multiplication. So the first thing we need to do when we solve addition problems using standard forms is that we need to make sure that the powers of the 10 is exactly the same. So in this case, we can make them exactly the same by reducing this to 5 to 5. We can make sure that they're exactly the same by reducing this to 5 in this case. So we can say 6 times 10 raised to power 5 plus. Now if we want to reduce this side by a value of 10, we need to increase this side by a value of 10, by a measure of 10. So this is going to be 30 multiplied by 10 raised to power 5. This is exactly the same as this, the value at least. And so now that we've done that, we factorize out 10 raised to the power 5. So this is going to be 6 plus 30. The common factor here is 10 raised to the power 5. There's a common factor of 10 raised to the power 5. So if we factorize that out, we have 10 raised to the power 5. And multiplied by that is 6 plus 30. And so this is going to be 36 multiplied by 10 raised to the power 5. Now don't forget that we're writing in standard form. We need something between 1 and 10. So we have to convert this back to 3.6. And because we're reducing this side by a measure of 10, we need to increase this side by a measure of 10, which is going to be 10 raised to the power 6. And that's the answer. We'll solve about 2 more examples. The next one is 8 times 10 raised to the power minus 2 plus 9 times 10 raised to the power minus 3. So we want to make it addition or subtraction. It's an addition sum, so we want to make the powers of the 10 similar before we continue with this problem. And to do that, you can choose any one, but I am going to be choosing making this 10 raised to the power minus 3. And to do that, I'll be reducing the value here. I'll be reducing the right side here by a measure of 10 because I'll be making this minus 3. So that means I need to increase this side by a measure of 10. So this is going to be 80 multiplied by 10 raised to the power minus 3 plus 9 times 10 raised to the power minus 3. Now that these are uniform, we can factorize this out. And if we do that, we would have 80 plus 9 multiplied by the common factor 10 raised to the power 3. And this is going to be 89 multiplied by 10 raised to the power minus 3. Now we need to write this in standard form, which means that we have to express this between 1 and 10. So that's going to be 8.9. And because we're reducing this by a measure of 10, we need to increase this by a measure of 10. And to increase this by a measure of 10, we add 1 here. This is going to be 10 raised to the power minus 2. Let's just solve one in subtraction so we can tell that it's exactly the same way. The only thing changing is the sign. So 6 times 10 raised to the power 5 minus 1 times 10 raised to the power 4. So if we make the powers of the 10 equal, if we reduce this to 4, since we're reducing this to 4, we have to increase this by a measure of 10. So 60 times 10 raised to the power 4 minus 1 times 10 raised to the power 4. So we do the same thing, factorize out the common factor, which is 10 raised to the power 4, and this is going to be equal to 59 times 10 raised to the power 4. So this is going to be in standard form 5.9 times 10 raised to the power 5. And I hope that by now I don't have to go through the whole explanation anymore. I hope so. Now we're going to solve one final one, which is 6.2 times 10 raised to the power 14 all raised to the power 3. Now in this case, we'll be needing another law of indices that says that a, b, all raised to the power n is equal to a raised to the power n, b raised to the power n. Now if that is the case, it means that this is equal to 6.2 raised to the power 3 multiplied by 10 raised to the power 14 all raised to the power 3. Now to evaluate this, we'll need another law of indices that says a raised to the power m all raised to the power n is equal to a raised to the power m times n. And this is equal to 6.3 square cube is equal to 238.328. And this is 10 raised to the power 14 times 3 is equal to 42. Now we need to write this in standard form, which means we would need to express this as a number between 1 and 10. And I know you know already that we would go for 2.38328. And because we've moved the decimal point 2 places to the left here, we've reduced this by a measure of 100. So we need to increase the other side by 100, which is add 2 to the power here. And that's going to be 10 raised to the power 44. And that is the final answer. And that's all about standard forms. I hope to have been able to learn a thing or two. I would advise that you watch the previous videos on laws of indices to be able to better understand the laws that we've applied here. And I'll see you in the next video, which is about laws of logarithm. Bye.